Good job. All right, kiddos, let's go ahead and get started on math. I want to start out by reviewing our DMR from yesterday on some of the problems that were a bit tricky for us. Overall, we're doing well on this DMR, probably because it's got such fresh skills that we've been learning and practicing, but there are a few that are tripping us up. So the first one is choose all the equations that correctly represent the fact family for this array. So when it says choose all, it's a pretty good hint to you or a context clue that you're going to be using more than one answer. When we look at this array, we see that there are 1, 2, 3, 4 rows of Fruit Loops. And there are 1, 2, 3, 4, 5, 6, 7, 8 Fruit Loops in each row. So our factors that we are multiplying are going to be 4 and 8. Our divisor and our quotients are also going to be 4 and 8. So I'm going to see which options have that. This has an 8, but it has a 5. That's wrong. This has a 32. It has a 4 and an 8. You know what? I got to figure out if this is 32. 4, 8, 12, 16, 20, 24, 28, 32. Oh, that song's fire. 32. Yep, so it's 32. So 32 divided by 4 equals 8. That's all of the numbers that are represented in this equation. Next up, we have our multiplication. Again, there's an 8, there's a 4, there's a 32. So 8 times 4 equals 32 also matches this. 12 times 6, there's not even a 12 on here. 4 times 8 equals 32. That's the same as option 4. It's just switched around in the numbers. So that is a correct answer as well. 32 divided by 8, that's the same as option 3. It's just the divisor and the quotient have switched places. So you should have had 4 answers checked for this equation. 4 of them. Count them. 4. 1, 2, 3, 4. 11, a question.
It's actually the inverse.
Yes, the inverse, which is a word that means the opposite. So that is correct. Thank you for the math vocabulary, sir. Good job correcting me. Paying attention, gold star. All right. We did pretty well on the next one. It was just straight multiplication. We did very good on this one because you were able to see, as 11 has reminded us, the inverse of these numbers, and the 8 was missing. We did okay on this one. I think some people were struggling. Remember, you can always, always, always still draw a picture. So 27 divided by 9, for me, I like to use equal groups. So I'm going to draw 9 different groups. There's 6, 7, 8, and 9. And then I'm going to put one item in each group until I get to 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Well, there's 3 in each group. So your answer should have been 3, your quotient. Okay. All righty. Last one. We did pretty good. Same story problem from yesterday. Ms. Sharp's class is collecting pine cones. Group 1 got 45. Group 2 got 29. Group 3 collected 73. How many pine cones did the class collect? The question that you are asked to answer is, which numbers in the story problem above will you need to combine to answer the question being asked? Well, I'm going to combine the number of pine cones, which is 45, 29, and 73. So my answer should say 45, check. 29, check. 73, check. Here's your correct answer. Okay, some of y'all selected these with the number 1 and 2. That's the name of the group, goobers. It's like saying table 1. You want to add the name table 1 to your total number of items in it. That's just the name of the group. So be careful when you are solving these. Any questions over that question or any others that we looked at on DMR?
It's 147.
Any other questions? Justin is giving us the answer. He believes it's 147. Tomorrow on your test, you'll solve that. Dun, dun, dun. All right, awesome. Let us get ready to move into continuing on with our division lessons. This lesson today is from yours truly, that's me. And we are going to take a look at our success criteria to start us off. Here is your goal for the day. Nope, you got to share the sound. There we go.
Weeks, we've been working on representing the concept of division of whole numbers using multiple strategies. The strategies that we have learned are partitioning, sharing, and the inverse of multiplication. We have also learned repeated subtraction and arrays in equal groups as ways to show sharing. You have also been asked to understand and use these words in your explanations of division. Today, you will practice determining which strategy is most appropriate when solving real-world division situations.
All right, so today we're going to take all the strategies that you've learned and we're going to see which one makes the most sense. As a quick overcap review, here's what we've learned about division thus far.
So far, we have learned 4 strategies for division. Today, we're going to begin practicing applying these strategies that we have learned to real-life situations inside of word problems. In order to decide which type of strategy is best, let's quickly review the strategies that we've learned so far. Beginning with repeated subtraction. 24 divided by 3 tells us that we are subtracting groups of 3 and deciding how many groups that would create. 24 subtract 3 gives us a difference of 21. With 21, I'm able to subtract 3 again. 21 subtract 3 is a difference of 18. I'm still able to subtract 3. 18 subtract 3 gives us a difference of 15. 15 subtract 3 gives us a difference of 12. 12 subtract 3 gives us a difference of 9. With 9, we're still able to subtract 3. 9 subtract 3 gives us a difference of 6. 6 subtract 3 gives us a difference of 3. And finally, 3 subtract 3 gives us a difference of 0, which means we are out of items to share. When we look at these repeated subtraction equations, we will count how many times we were able to subtract. 1, 2, 3, 4, 5, 6, 7, 8. I was able to create 8 groups of 3. So according to repeated subtraction, my quotient to 24 divided by 3 would be 8. Then we moved on to learning about equal groups. With 24 divided by 3, we can look at this as creating 3 groups. Then we would place one item in each group until we got to a total of 24 items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. When I count the items in one group, I'm able to see that there are 8 items in one group. So my quotient for this strategy is the same as the previous strategy. When we're looking at drawing with arrays, we put our objects into rows and columns. 24 divided by 3 tells me that I should create 3 rows. 1, 2, 3. And I'm going to place one additional item in each row until I get to 24. We started at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And when I count, I am able to see that there are indeed 8 items in one row. So again, our quotient is 8. As you can see, passing out items one by one does take some time. So partitioning is something that can help us move a little bit faster inside of our work. we know that we need to get to 24 items. So instead of passing out items one by one, we can look at our groups as buckets and we can drop a few items inside of the buckets until we run out of items. So I know that 24 is an even number, so I'm going to try to divide by an even number. But 24 divided by 2, I think 2 is still too small. I might try to divide by 4. Let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, that gave me 12 items. So 4 worked out pretty well. I know that I still need to add more to get up to 24, so I'm going to try to do 2 this time. Let's see if it works. You know what? That would be smaller than 12. I'm going to try 3. So 4, then I'm going to add 3. This gave me 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so when I added 3, that got me up to 21 because I added 9 more. I need to get up to 24 and I'm at 21. That's only 3 away. So I could put 1, 2, 3
in each group, and that would get us up to 24. So there are your 4 strategies that we've learned for division. Now we're going to take a look at how to decide which strategies are the best to be using. That was just the finishing of the video. So we're going to look at real world examples and we're going to decide if I were going to solve this in the real world with a real object, with a real person, what would happen? What would my actions look like? Would they look like making an array? Would they look like taking things away from a group and subtracting? How would they look? So here's an example of how we would use a division strategy in our daily life.
Today, you are being asked to read word problems. You will decide which division strategy is best to solve the equation. Then, you will explain why you chose that strategy. In this word problem, Ryan wants to create a community garden. He wants to plant 36 vegetable plants, and he has 4 types of vegetables to plant: corn, carrots, onions, and potatoes. If he wants to plant an even number of each plant, how many of each will his garden grow? I know that even here is a synonym for the word equal, so he's wanting to plant an equal number of each type of plant. So I'm going to think about whether I'd like to use groups, array, repeated subtraction, or partitioning. I'm thinking about the way a garden looks. In my head, when I think about a garden for a community, I think about a wooden rectangle box with soil inside of it. I know that rectangles look pretty similar to arrays, so I'm going to try to draw an array to solve this equation. I have 36 vegetables. So when I'm going to decide how many to plant, of each plant, I have to look at the types. There are 4 types. In my head, I imagine a row of corn, a row of carrots, a row of onions, and a row of potatoes. So I'm going to try to create an array that represents this. I could plant a carrot, a corn, an onion, and a potato, and I have 4. And then I could continue to plant 1 of each until I get to 36. So that's 8, 12, 16, 20, 24, 28, 32, 36. There is my 36 plants. When I count how many of the corn I planted, I see 9. How many carrots is also 9. Onions, 9 again. And potatoes, also 9. So, Ryan could plant 9 of each type of plant. Ryan could plant 9 of each vegetable. And that is my answer. Now, I'm not done, ladies and gentlemen, because I've been asked to explain why I chose this strategy. So, I'm going to use the voice recording that's already turned on to explain this. I chose to use an array because a garden can look like an array with rows and columns where plants represent the dots that we see inside of an array. And that's it. So today, you'll read a word problem and you'll decide which strategy does that look like in real life? Which strategy makes the most sense to use? You'll also record your voice explaining why that strategy makes sense for the situation.
All right, so this is what you're going to do today. You're going to see word problems and you're going to decide which strategy makes the most sense. Okay, 1 second, I respond to something. All righty. Inside of your add responses today and your activities are going to be several different word problems. I'm going to place you up into some breakout rooms today where I'm going to hop in and out and listen for that teamwork. You are going to click the add, and for each slides, number 1 through 3, you're going to read or listen to the word problem. You're going to solve using the strategy you think is the most appropriate for the situation described in the word problem. That means you're going to choose which model makes the most sense. Use the microphone to explain why you chose that strategy. Use math vocabulary in your recording. Be sure you have written and recorded on all 3 slides. Reflect on your success on slide 4 and click the check to turn in your completed work. So just quickly, before I set you in there, I will show you the 3 different word problems. On slide 1, there is a word problem, and again, the directions said you can read it on your own, or if you do better hearing, you can click play and listen to my voice read it to you. I've also included right here an example of each of the strategies that you have learned so far. I've also included the math vocabulary that I should hear you say when you record your explanations. Okay? It's the same for each equation or each slide. There's just a different story problem in each one. What questions can I answer about the assignment expectation before I put you into some breakout rooms? What questions can I answer? Any at all? Okay, awesome. We're going to break this up into chunks. So the first time you go to a breakout room, you are only going to do slide 1. Okay, I'm going to give you about 6 minutes to solve slide 1 by showing a model of a drawing and recording your vocal explanation. Okay, then we'll come back and we'll review that slide and I'll send you back to work on the next one. Okay, so show me with your fingers. Which slide are you going to finish right now? Show me with your fingers. Which slide? Levin's got it. Aiden's got it. Terrence almost had it. He's kind of got it. He's halfway. Oh, there it is. He's got it. William's got it. Sinq's got it. Alrighty, welcome back. I was pretty impressed with what I was seeing as I was looking at your screens. Oh man, I wanted Steve to share, but it looks like we might have lost him in the shuffle. Okay, let me take another look here. Let's see this. Oscar, would you mind sharing your screen with us so we can take a look and you can explain your work?
Okay.
Awesome. So go ahead, Oscar, and tell us what you did to solve the problem.
So I just put like 4 rectangles and I put like dots on each one of them.
And why did you choose this equal groups picture?
Because like this is like a this is like a easier way to do it. Like a easier way to do it.
Okay, so this strategy makes sense to you. What do your rectangles represent in the word problem? What
They
are they?
like they represent like the groups.
Yeah, and the groups are the tables inside of this word problem. So people were sitting at tables. So Oscar, how many people are going to sit at each table? I think he's chopping up. We can count his dots here. 1, 2, 3, 4, 5. Oh, it went away.
It's frozen.
Oh, it's frozen. Well, he had 8 dots there, 8 dots representing those groups that we saw. Awesome. So this is a real life example of how you can solve an equation with the way it would look in a situation that you were trying to solve, like up throwing a party. All right, next up, you are getting ready to move on to slide 2. Slide 2 is what you are getting ready to solve. This will be the last one that we are going to solve together in your breakout rooms. So slide 2, you have a situation about Miss Kaylee, and Miss Kaylee would like to make bracelets. Remember, you are choosing the strategy that makes the most sense in a real life situation. What would actually be happening when Kaylee is working with these bracelets, okay? So think about, would this look like groups, arrays, repeated subtraction, or partitioning, okay? So you are looking at what would actually be happening in a real life situation. Here are your invites.
You missed the recording.
I know, I just missed the recording, and I'm so sad because Steve Rogers just did a beautiful job explaining repeated subtraction. He told us when you think about giving away items over and over until you have none left, the idea of repeated subtraction usually comes to mind. And I agreed with him. And I actually want to cry because I missed his awesome use of vocabulary. But Steve, you did wonderful. This is the evidence. All right, ladies and gentlemen, we are getting ready to wrap up. You have 1 slide left that you will be completing during your independent work time. There were 3 word problems assigned to you. We solved 2 in breakout rooms. You are going to solve the 3rd independently. Again, you can read the problem or you can listen to the problem by clicking play, and you are going to create the strategy that best matches the real life situation. On slide 4, I would like for you to move the star to explain how you feel about using division strategies with where you think you are on your work, okay? Second reminder is that during your STEM work time, you are to be working on Zearn and Prodigy. I shared with you on announcements yesterday that if I do not start to see people on Zearn every day when I am looking at your screens like this, if I don't see Zearn popping up, hold on, boom. If I don't see Zearn popping up like I do over here with your Seesaw, then I'm going to start assigning it as a Seesaw activity where you have to take a screenshot, okay? That Zearn is just like Lexia for your reading. It goes back and reteaches you things that you need to know. It challenges you on things that you already know. So you need to make sure that you are completing 15 minutes of Zearn every day, okay? So finish your Seesaw assignment, work on Zearn for 15 minutes. Any extra time can be spent on Prodigy.